Okay, so we're still working on the problems that have to do with identities. And these are the even problems from homework task 9. We had done up until problem 26. And we're going to continue with problem 28. So I'm going to switch over here to the whiteboard. And we're going to jump into it, okay? Remember that I'm solving these here in class, but I encourage you to try to do them while I'm doing them, for you to try to do them in your notebooks. And as we've been mentioning a lot throughout, there's more than one way to solve these. So you can we can verify that as well. Okay, so let's look at problem 28. I'm going to switch cameras as well. Okay, so problem 28 is, let me turn off the lights here. And I'm going to switch microphones as well. So you guys at home should hear me better like that. Okay, so we're going to go with problem 28. Remember, what we're doing in these problems is that we are validating identities. And so basically we have a mathematical expression equation to the mathematical expression where we've got two sides, the side on the left and the side on the right. And these are different, but they are equivalent. We're trying to demonstrate that they're equivalent. And we can do that in many ways using the trigonometric functions. So let's work on problem 28. So problem 28 says, and again, please follow along. There's more than one way to do these. And also, if I make a mistake or something, then call me out, please. So we've got tangent squared of x minus sine squared of x equals tangent squared of x multiplied by sine squared of x. Okay. And remember that we can work on either side to make the left side look like the right side, or the right side to look at the like the left side. So I'm going to start working on the left-hand side. And one thing that we know we can do is we can turn everything into sines and cosines. So I'm going to do that right now. I'm going to say that tangent is sine squared of x divided by cosine squared of x minus sine squared of x. Now, the next thing I'm going to do is that I'm going to take a common denominator here. And the common denominator is going to be cosine squared of x. This is going to give me sine squared of x minus cosine squared of x multiplied by sine squared of x. I've been noticing when I'm doing these exercises that some of you are struggling to visualize the common denominator thing. I think that's important. So remember that when we've got a fraction, or rather two or more fractions that we're going to add or join, we're going to choose a common denominator. And the common denominator is actually going to be the simplified product, or just a product of the denominators. And what we do is that we validate or verify that denominator in each of the elements, and we divide by that, and depending on the result, we multiply so it is equivalent. So in this case, cosine squared is the common denominator because sine squared is divided by 1. Cosine squared divided by cosine squared is 1, multiplied by sine of x is sine of x. Cosine squared divided by 1 is cosine squared multiplied by sine squared of x. That's what gives us this term here. Once we have that, Now we can factor the sine squared of x. And that's going to give me 1 minus cosine squared of x, correct. Divided by cosine squared of x. We know that 1 minus cosine of x, what is that? Or what can we substitute that for? Yep. So, no, sine squared, because remember that we've got the Pythagorean, the Pythagorean identity here. So sine squared plus cosine squared equals 1. If we send either of those to the other side, we get 1 minus that identity. And so, by doing that, we're actually going to have sine squared and cosine squared. This is going to give us tangent squared. And that gives us the result we want, which is tangent squared of x multiplied by sine squared of x.
We just need to do one side.
Yes, we just need to demonstrate the identity. You can do one. You just need to do one. I'm doing both or more here just so you guys have the example, but you can just. You have a question?
I don't understand how you factorize
The last one?
no, about that. I don't understand how you.
Okay, so let's see which is this one? Okay.
Yeah, that's okay.
Okay, so what we're doing here is that we're grabbing sine squared. This is a common L factor in both of them. So we're factoring by sine squared here. So sine squared divided by sine squared is 1 minus cosine squared sine squared divided by sine squared is cosine squared. Okay, so we're factoring that. And then 1 minus cosine squared is equal to sine squared. Okay, so in the end, this is the same as having sine squared of x multiplied by sine squared of x divided by cosine squared of x. So we're trying to get to this. So we can identify that this is tangent squared.
Can the cosine is not dividing the both sides?
It's dividing both of them, but remember that when you have a factor in the denominator, it is dividing both of them, but this is the same as when you have A multiplied by B divided by C, this is the same as having A divided by C multiplied by B, or A multiplied by B divided by C. So if everything is multiplying, the factor in the denominator can go to either of the factors.
But if it's adding or subtracting?
If it's adding or subtracting, so this is if it's multiplying, but if it's adding or subtracting, that's different. If it's A, B, A plus B, C, this would be A divided by C plus B divided by C. Okay? And that's just because it's the commutative and associative clause. Okay. So is that clear as well, Ivan?
Yes.
Okay, so this would be, I'm going to call this path 1. This would be one way of doing it. Now let's see if we can work on the other side. Here, well, this is the same as what we were looking at. Okay. So now the other one is working on the other side, and we can do what we could do there is that, well, there's a bunch of things we can do there. So we could also turn everything into sine and cosine. We can kind of do the inverse of what we did. So we've got first off, we're going to do this. So we've got tangent square root of x. And sine is the same as having 1 minus cosine squared. Using the Pythagorean theorem. Tangent is going to be sine squared divided by cosine squared. Multiplying these, we're going to have sine squared of x divided by cosine squared of x minus cosine squared of x divided by cosine squared of x. These two are going to eliminate. Well, I don't know. Wait a minute. No. I made a mistake here. Sorry, we're multiplying this by this, so we're going to have sine squared of x cosine squared of x minus sine squared of x cosine squared of x divided by cosine squared of x. Now these two are going to eliminate. And sine squared divided by cosine squared is the tangent that we already have, but now we've separated it, and this is sine squared of x. And that's exactly the same thing we had on the other side. And these two are. Yes.
How did you get on step 2 to step 3?
From here to here. Okay, so let me just take a quick screenshot of this. Okay, so so here, so this part is understood, right? The tangent, I'm just making that sine divided by cosine, and the sine, I'm making it 1 minus cosine. So what I'm doing now is that this factor here, I'm multiplying it by each of these. Okay, so sine squared cosine times 1 is sine squared cosine squared. And then sine squared cosine squared times cosine squared is just multiply, and then we just eliminate. Okay, questions with this one? Okay. Clear. So I'll close the parenthesis now, and those of you who went to your happy places can return. Let's go with problem 30. Okay. Problem 30. Okay, so problem 30, we've got sine of x plus tangent of x divided by 1 plus cosine of x. And that's equal to tangent of x. So there's a few things we can, there's again, many ways to approach this. I'm just gonna turn, I'm gonna work on, since we only have tangent of x on the right-hand side, it really doesn't make much sense to work on the right-hand side because we have just one trigonometric function, so we would need to really multiply by things and unravel to get to the part on the left. So in this case, it really makes sense to work on the part on the left. So I'm gonna turn everything into sine and cosine.
The one on the bottom would be negative sine of x.
This one here?
Yes.
No, because we don't have it squared.
Yes.
We can only use the Pythagorean when it's
Yes.
when it's squared.
But we can change the one to a trigonometric, right?
Yes, we could. Again, there's many paths we can follow here. What I'm going to do here is on the numerator, I'm going to use a common denominator, which is going to be cosine of x.
You have a question.
Yes.
Couldn't we cancel out the cosines of x from right there?
No, because remember that you can only cancel out factors. So factors means that things are multiplying. If you got a plus or a minus or things are adding, you can cancel things out. And so I'm just joining in the numerator, I'm joining these two. And I'm going to be doing a tortilla law here. And I'm going to continue over on this side. And so by doing that, I'm going to have sine of x times cosine of x plus sine of x divided by 1 plus cosine of x multiplied by cosine of x. And we can factor here on top, we can factor the sine of x. The sine of x is a common element there. So we can have sine of x multiplied by cosine of x plus 1. This would give us 1 plus cosine of x times cosine of x.
How did you do the one of sine of x times cosine of x plus 1?
Okay, so we're up here. So up to this point, we're okay? The tortilla? Okay.
Okay, yeah, no, yeah, I already understand.
Yeah, we factor the sine and then we get the.
Yeah.
And the cosine of x plus 1 and the 1 plus cosine of x are going to eliminate. And we're going to be left with sine of x divided by sine of x, by cosine of x, and that is 10.
Teacher, I have a question.
Yes, go ahead, Leo, please.
How do you get rid of the sine x in the third part?
In the third, in
The arrow one, yeah, the one with arrow.
this one, okay, so up to that point, we're okay?
Yes, yes,
Oh. So here, Leo, we identify that we have a common factor. we've got sine of x here, and we've got sine of x here. Okay,
Yes.
this is common. So if it's common, we factor. And that's what we're doing here. So we're taking the sine of x, and sine of x times cosine of x divided by sine of x is cosine of x, and sine of x divided by sine of x is 1. So we're factoring the sine of x. Okay?
Yes. Thank you.
Okay. And then this gets a little.
Let's go. Te digo una canción.
Looking out the window. I saw something. No sé en cuál liga juega.
Está diciendo si le echan a Juana, él no va a conseguir un equipo. El Charlie, si no echan a Juana, a ver si le dan papeles. Señor Clemente. Bueno, vamos a ver, ¿no? Si lo estás platicando, es que no debería, cuando se va a hablar, hasta la voz, una vez vi Tom Scorer, Arturo Clemente. ¡Ay!
Okay, questions with this one? Over at home, how are you doing? Questions?
El Junior.
Okay. I'm going to clear and go to the next one. So we've got 32.
¿Cómo estás?
So 32, we've got 1 plus sine of x divided by cosine of x plus cosine of x divided by 1 plus sine of x equals 2 seconds. 2 seconds. Okay, so there's many things we can do here. So
Can 2 seconds be 1 second plus 1 second?
What you can separate that into seconds plus second. What we're going to do here, what I'm going to do here is that we are going to join these two. We're going to use, and that can also help us practice our common denominator. So again, when we're talking about a common denominator, we've got 2 fractions here. So the common denominator is going to be what we have on the product of the 2 denominators in this case. So we're going to have cosine of x multiplied by 1 sine of x. That's going to be the common denominator. And again, what we do with the common denominator is that we're going to look at the expression and multiply by the factor that's missing. So in this case, for the first expression, the common denominator is cosine of x plus multiplied by 1 plus sine of x. So what's missing is the 1 plus sine of x. So it's going to be 1 plus sine of x multiplied by 1 plus sine of x. For the second factor, the cosine of x multiplied by 1 plus sine of x, what's missing is the cosine of x multiplied by cosine of x. That's going to be cosine squared of x. And actually this, what we have here, this is actually 1 plus sine of x squared. It's the same factor. So let's do that. Let's do this here. This is going to be, if it's 1 plus sine of x squared, it's going to be 1 plus 2 sine of x plus sine of x squared. This is just the product of these two, or elevating the binomial to the square, plus cosine squared of x divided by cosine squared of x and 1 plus sine of x. So what we know, what we can see here is that sine of x plus cosine, sine squared of x plus cosine squared of x, this is going to be equal to 1. And we're going to bring this up over here. This is going to be 1 plus 2 sine of x plus 1 divided by cosine of x, 1 plus sine of x. 1 plus 1 is 2, so this is going to be 2 plus 2 sine of x divided by cosine of x and 1 plus sine of x. Here we can factor the 2. We have 2 multiplied by 1 sine of x divided by cosine of x and 1 plus sine of x. The 1 plus sine of x is going to be eliminated. We're going to be left with 2 cosine of x, which is equal to 2 times secant of x, because 1 divided by cosine is secant.
No, can we divide at the beginning? And substitute 1 over cosine is going to be equal to second, and then plus tangent plus cosine plus tangent. But I mean, that's why
We could divide this one if we wanted to, like you're mentioning. Or we could divide this one. We could separate this one into 1 divided by secant plus tangent. If we wanted to, we could do that. The problem we would have is with this one here. What do we do there?
yes, I'm very confused. It's not going to be second, but I mean, one. We are dividing.
Oh, yes, you're right. This would be just second.
Yes, I'm studying in that part when I'm doing it like that. But I don't know how to get the other second.
That would be you've got 1 second and you would need the other one there. There would be some sort of manipulation that we would need to do here. We have to do with this one. What can we do there?
let's see, let's noodle. Let's noodle on that. I'm gonna call this path 1. Let's see how else we could. I'm gonna call this path number 1. Okay. And let's noodle a little bit on. Let's see what we could do if there's some sort of other manipulations that we could do there. Let's see if it's not more complicated or confusing, but let's see what we can do here. So question with this one before I clear it, and let's try another way of getting to the same thing. Yes.
I usually took this step 4 to 5.
1, 2, 3, 4, from here to here?
Yeah, I really understand
Okay.
how you distributed the 2.
Okay, so here, we're always going to try to be looking for common factors. So we've got a 2 here. So we've got a 2 here. And we've got a 2 here. That's going to be the common factor. And that common factor, we're going to bring it over here. And we're going to say 2 divided by 2 is 1. 2 sine of x divided by 2 is sine of x.
But does it matter if it was multiplying the 2 sine of x?
No, because we're using it as a common factor, so we're bringing it out. That's why the common factor is 2, and so 2 multiplied by 1 sine of x is going to give you what do you have here?
Oh yeah, I'm trying to understand because here it'd be like 1 times the sine of x, because if you distribute the 2, I don't think it's going to give you the 2 sine of x.
No, but it's correct what you just said. It's 1 sine of x, so 2 times 1 is 2. It's the same as having, so basically what we're doing is this. So imagine if you have a plus a multiplied by b. Okay, the a is the 2, the b is the sine of x. So what could you do here? You take the a divided by a is 1. A and plus. A divide a plus a a multiplied by b divided by a is b. So the a is the 2, the 1 plus b is the sine of x. So this is just practicing the fact. Okay, so let's see if we can do something else here, or do it another way. So I'm going to call this path number 2. Okay, so let's go with what Hoyle was saying. So let's see if there's another way to approach this. So we're going to have to be a little bit creative. So we're going to take this first factor. I'm going to divide this 1 divided by cosine. Plus sine divided by cosine. And for now, we're going to leave this factor as it is. Plus cosine
divided by 1 plus sine of x. So here what's going to happen is that this here, this is going to be second. And this is going to be tangent. So now we're going to be left with second of x plus tangent of x plus cosine of x divided by 1 plus sine of x. So as Joel noticed, well, that's good because I need 2 seconds. I already have 1. But I need another one. So I'm going to have to do something, and I need to eliminate that tangent. So I'm going to have to do something with
Can you get it with the 1?
because it's in the denominator. That's the problem.
But you have Pythagorean identity.
We're gonna need the Pythagorean identity. But the problem right now, the way we have it right now, is that everything, nothing, or rather, nothing is elevated to the square. For the use of the Pythagorean identity, we need them to be elevated to the square. Now, there's a trick we can do here. There is a theorem. Oh, this is an algebra. Algebra theorem. I'm going to write it down here. That says if I have x plus y, and I multiply that by x minus y. So it's x and y. One factor is plus, and the other factor is negative. Does anybody know what this gives me?
1.
Nope.
Son computados.
It's x squared minus y squared. So it gives me the x squared, the y squared, and it's negative. So this is a theory. So if I have 1 plus sine of x, it would be really cool to multiply. If I could multiply this by 1 minus sine of x, what would I get? I would get 1 minus sine squared of x. And I know that this is equal to cosine squared of x. Would you agree that that would be useful? But I just can't multiply by that because it's going to alter the equation. However, if I multiply anything by 1, nothing is altered. So if I want to multiply in the denominator by this, because it would be useful, if I multiply by the same thing in the numerator, nothing is altered. So, yes, so this factor that I just added here, this is 1. So I'm multiplying by 1, I'm not altering it. I'm just adding that because it's beneficial. So if I do that, what I'm going to get is second of x plus tangent of x plus cosine of x multiplied by 1 minus sine of x. And in the denominator, these two multiplied are going to give me cosine squared of x. Now I can separate everything. Bring this over here. So this is going to be second of x plus tangent of x plus cosine of x minus cosine of x sine of x divided by cosine squared of x. Now, the same way I separated the factors at the beginning, I can do the same thing here with this. And this is going to be equal to secant of x plus tangent of x, cosine of x.
Fine, it's like that.
I'm just going to leave it here and I'm going to do the eliminations in a moment. Minus cosine of x, sine of x, by cosine squared of x. So when I do that, the cosine is going to be eliminated with the square. The cosine is going to be eliminated with the square. And what I'm going to have is secant of x plus tangent of x plus, this is going to be 1 divided, this is going to turn into secant and this is going to turn into tangent. It's going to be secant of x plus secant of x minus tangent of x. The tangent is going to be eliminated, and secant plus secant is going to be 2 secant of x. So this is a little bit more elaborate, but it's another way of doing it.
Then it was going to be easier.
It's
So we can do that, we can multiply like 20.
whenever it helps our motives, meaning whenever it helps to do any sort of reduction or simplification, whenever we multiply by 1, we're not affecting anything. So we remembering this identity here, the x plus y times x minus y is equal to x squared minus y squared. We can use that to create or incorporate a Pythagorean identity where there originally was none. Taylor Swift?
Oh, that's
Really? Is that Taylor Swift? No, that's not Taylor Swift. That's
That wasn't one wonder. That's that.
no, it's not Taylor Swift. Oh, I don't remember the artist, but yeah, it was a one-hit wonder.
Creo que la de saber la diferencia.
Anyway,
Carly Rae Jepsen. Call Me Maybe. Carly Rae Jepsen.
yeah.
Yeah, mi nueva bien.
Yep, 2012. Dance Party 2012.
Pero estoy bien, ¿no?
One-hit wonder. Let's see if we can do a few more. Okay, I'm gonna clear these. Let's go. We're up to 32. Let's look at 34. So it's sine of x plus tangent of x divided by cotangent x plus cosecant x. Equals sine squared of x divided by second of x. So there's also a couple of ways to do this one. Let's first try the surefire way where we turn everything into sine and cosine. Once we do that, we're going to do the common denominator thing again. So over here, the common denominator on top is going to be cosine. And that's going to be square root. In the denominator, no, not yet. We're just grabbing this here. We're grabbing this here as the common denominator. So this is going to be sine of x multiplying cosine of x plus sine of x. And in the numerator, the common denominator, in the denominator, the common denominator is going to be sine of x. And this is going to be cosine of x plus 1. We'll do the tortilla law here. That's going to give us sine of x multiplying sine of x times cosine of x times sine of x. And we have cosine of x multiplying cosine of x plus 1. Now here in the numerator, we can multiply everything. We're going to have sine squared of x times cosine of x times sine squared of x. That's just multiplying by the sine. So nobody started singing the Ace of Base song. It should have been obvious what we're doing this one. Oh, it's trivia. Google it. Sine of x, sine squared of x. We see this, it's the common factor. So we factor it, and this is going to be cosine of x plus 1. Divided by cosine of x and cosine of x plus 1. Cosine of x plus 1 is going to be eliminated. We're going to be left with sine squared of x. And 1 divided by cosine is second. That would have been an obvious song while we're talking about science. Sine.
The one from Pitch Perfect, right?
Excuse me?
That's the one from Pitch Perfect.
Is it? I haven't seen that movie, but yeah.
Did you do like musicals?
Yes, a lot.
These are I really don't know how to say it. Do you saw or do you see?
Did you see?
Did you see Tick Tick Boom? No. Say yes. Tick, Tick.
No.
With Andrew Garfield. It's on Netflix.
No, is it good?
Well, I really liked it. It's not like a great story. It's kind of sad, but I liked it.
Serious.
Yes.
Spoilers, no spoilers, Daniel.
Dije.
I was watching it in program.
Se hizo en 1995.
The movie's from 1995?
No, is that it's based on a true story, but some things are exaggerated because it's not a documentary, but it's about the guy who created Rent. The music.
Oh, I know which one you meant. You saw, yeah. I saw the trailer.
It's
Yeah.
not worth it.
Yeah, I wanted to see that one. Yeah, the Rent is really cool. Yeah, I haven't seen it, but I have it on my
It's
bucket
good.
list.
I didn't like that it had like no ending. I don't know. It's like it was
It just finished.
just okay. Okay. But I really liked it. It's from the one of Hamilton, so
From Lin-Manuel Miranda, or- Oh,
Yes.
Hamilton is really good. Really, really good. I highly recommend that one. Okay. Okay, question with this one. Okay, I'm gonna clear. Let's see if we can do
We
a
can just
couple.
bring the last part,
This one?
no. I'm sorry, that,
Okay,
the last step,
from here to here?
yes.
Okay. So we're okay to hear that we factored the sine squared of x?
Yes.
It's common factor. And so we get this, and so the cosine of x plus 1 and cosine of x plus 1, those get eliminated, and so we're left with sine squared of x divided by cosine. And so this is the same as having sine squared of x multiplied by 1 divided by cosine. And the 1 divided by cosine would be the second.
it kind of is funny, like how you do everything you can to make it work. Like every single math trick you know, you can use it here too.
Yeah, it's part of the things that have to do with these exercises that I think they mentioned is that well, this and a lot of math, and you're gonna be I think you're gonna be learning this throughout your studies as engineers. You're gonna learn a lot of things in class. You're gonna practice a lot of things, but a lot of engineering also has to do with creativity and linking stuff. So kind of learning some tricks is gonna help you. Right now, we're solving math problems. And again, I think I mentioned this and I'm stressing it again. The objective of this is for you to develop these skills to identify models that are going to help you. Well, some mathematical principles that you're going to need in more advanced engineering classes, but also for your brains to start identifying models and structures. So the objective of this and what we're seeing in this class, it's not because you're going to, finishing this semester, you're going to put a stand outside of your house that says, I solve trigonometric identities. For 10 pesos, for $2, for $5, I will solve trigonometric identities. It might help you at the party with the person you want to talk about, but that's not the objective of this. The objective of this is for you to develop identifying things, and by identifying them, learn, okay, I can do this trick or I can unravel this. That's what you need to learn as engineers. I was teaching a class for the 5th semester. I teach a class for the 5th semester IE Global programs, which is the industrial electronics class. And we were doing a lab exercise, and it's one of these, it's not a really complicated circuit, but if you're not used to working with electronics, it might seem complicated. So the students were doing the circuit, and one student, she did the circuit and it didn't work. And the first reaction is, if it doesn't work, oh, I want to rip it apart and try to do it again. And I'm like, no, we need to find the error. And we started working through it, and we found that there was a particular error in the circuit. And once we corrected that error, the circuit worked. and I mentioned to the group, and I'll mention it to you guys as well, one of the, if I were to tell you two things that I would, you're in first semester right now, but two things that I suggest you try to incorporate into your skill set, because I think it's gonna make you, it's gonna help you get a job, and it's gonna help you get a good job and grow, is a couple of things. And you don't have to have both things. But if you have either of them, they're really useful for any organization. One is troubleshooting. Does everybody know what troubleshooting means? It means finding the problem. Notice what I said. I didn't say find the solution. I said find the problem. So something isn't working. A plane crashed, and we want to find out why the plane crashed. Why? Because we need to correct that. A system isn't working, a circuit isn't working. We need to find out why it isn't working. Developing that skill is really, really useful. And they're very high-paying jobs where you can use that skill. And the other is to be creative and innovative. So I think this, Dr. Shum touched upon this when he gave you guys the talk. But if you're, I'm sorry, if you're a person in an organization that can find creative and innovative ways to do things, you're going to be valuable to the organization. And the rest of the skills are things you should develop, which are obviously important, being on time, turning in things on time, etc. But those two things, being able to troubleshoot and being innovative and creative, those are really important skills. And at least the first one, the troubleshooting one, you only get that by practicing and getting experience. I remember I once, well, not me, but a group of colleagues, we were doing a consulting for a company for an automation system, and the system wasn't working. And I remember that we made $800 that day just by turning a knob. That's because in the company they didn't know why the machine wasn't working. And because it was a machine that they hadn't built, that they had just installed and it was working. And the thing is that the machine wasn't calibrated. The machine, it's an interesting sort of machine. So if you have have any of you thought about how they package toilet paper? Toilet paper comes in this huge roll.
They got it.
Yeah, but I'm exaggerating. I'm doing this too small. The toilet paper comes in a huge roll. It's a huge roll. It's a huge roll of toilet paper. And from this roll, you make the smaller rolls. So basically there's a machine that feeds paper from the large roll to the small roll, and when it gets to a certain size, it cuts it, and that makes the larger roll. But let's see, you guys, as engineers, toilet paper is very thin, right? So this is a large roll, and this roll is turning, and it's feeding paper into this roll that's turning here. But what's the problem that can be generated there?
The tension will break the paper.
Yeah, you have to be very careful with the tension. Because, and is the tension constant?
It should be.
It should be, but it's not, because the larger roll is going to start getting smaller, while the smaller roll is going to be getting larger. So you don't have the same tension, and you have to regulate the tension. How do you regulate the tension? This is movable. This goes up and down, and this goes up and down as well. And so by moving up and down, you regulate the tension. The problem with the machine was that this was breaking, and these weren't regulating correctly. And they had these machines that they had no manuals. They didn't know. They just brought the machine and they installed it in the company, and they didn't know what was happening. So this wasn't going up and down correctly. So if I ask you about troubleshooting, and you don't have to know the specifics of this, what would you look for how would you look for the problem? There.
Well, it's easier to open and see how each part works. And then try to
Okay.
assemble it, but it's a big machine, so it maybe more work. But maybe it has a computer or something where you can read the specs and how it should be working. And you can see like individually each part. And
So first, what you're saying there first is we need to understand it as a system and understand what parts it is, and there has to be some sort of controller or circuit. Problem is you don't have any, and let's add another variable. Let's say it's an Italian machine. So anything you have on the board is in a language you don't know. Maybe some of you know Italian, but we didn't know Italian, okay? But the problem there is that if it's not going up and down correctly, it means the problem is that it's not calibrated correctly. So we need to find the circuit that calibrates it. And so that's what we did. We found the circuit that calibrated it. So it was a little board here. And it was a board that had these knobs. We noticed that it had these knobs. And we noticed that the knobs corresponded to certain parts of the system. So we started troubleshooting and we said, okay, put the machine to work. What happens when we move this knob a little bit? And we noticed that when we moved the knob, it started going up and down quicker. If we moved another knob, it started going up and down slower. So the only thing we did is we started moving the knobs until the calibration was correct. Obviously, we were doing this, the people from the company were over there waiting for the solution. When we finished, it's like, the machine is working. Wow, that's great. Give us $800. And they gave us $800. We were students, by the way. We were students in 8th semester. This was 19. So $800 doesn't seem a lot to you guys. And $800, there was 4 of us. So it was $200 a piece. For one day's work and just moving a knob. But this was 1990.
there you go.
This was 1996 or 1997 when we did this. So troubleshooting, you guys. And going back to Daniel's comment, you only get that by practicing and by experience, again, in identifying models. So again, the purpose of doing these identities and doing these exercises in math and physics and whatever is for you to identify these models and start practicing that. Okay, let's try to do one more here. The 4 of us, we wanted to do a company, actually the 4 of us. In the end, we noticed that some of us weren't really cut out for entrepreneurship in that sense. And actually the company is still active right now. It's called Automation something. And one of the 4 of us still stayed with the company. But yeah, we did that in 4th semester.
So like engineering at work, it's more of knowing how to solve problems instead of like doing the math.
Yep. Totally and completely.
Learning the math for a logic, like part of the brain to work.
Well, that's one thing, but another thing, and this is something that companies have told us as well, that's one part. So in real life, this is something I told me, in real life, wherever you're working, they're gonna give you a problem, and it's not something you're gonna be able to go to a textbook and say, oh, this is the solution to the problem you're giving me. You have to develop that. So that's part of it. The math is important for that, but the math is also important because you might have to solve problems that seem very complex, but you're gonna need some fundamental engineering math to do that. And companies tell us this, or have told us this, that sometimes when I was studying, we had computer software, but we didn't have as much use of it. So you need to know how to do things by hand. So I'm going to give you a weird example. Do any of you know how to calculate a square root by the mathematical method to calculate a square root?
Kind of, you need to know to calculate roots. Well, how I remember, like when we see, we need to know first the ones that are exact, and from them like try to guess.
Well, the-
I remember that.
What?
You made a tree, you have to go.
Yeah, there's a method to calculating.
I remember doing that,
That's weird, that's curious that they taught you how to do that, because that's not something that they teach anymore. Before we didn't have calculators, we had rulers to do calculations, then we got the calculators. So more and more we're dependent on computers. And one thing that companies have told us is that it's important for students to also know how to do the math, to know how to do it manually, because you're not necessarily always going to have the computer there. And that some young engineers are, if they take away the computer from you guys, you're totally frozen and don't know what to do. Not you guys, I mean, young engineers.
Let's say I'm working. Am I going to need to like sacar derivadas integrales? No, right? Like there's no, or.
It depends on where, it would depend on where you're working, what you're doing. You might need to, I'm gonna say it this way. You might not need to be doing necessarily derivatives and integrals as part of your work, but maybe you're in charge of a production system and you need to either develop a system or a model to do quality testing, and that is going to have to do with statistics. And for some statistical models, you need integrals to understand them. Or maybe you're not going to have to develop it, but again, this is another takeaway. You are not going to be always in charge of systems that you design. So you might be implementing a system that somebody else designed, and there's going to be a mathematical model behind that, and you're going to need to understand it. And that mathematical model is going to have integrals, derivatives, statistical models, whatever. So you're not going to have to develop it, but you're going to have to understand it. Okay. The true thing is that, and this is kind of the trick. The higher you get in the organizational ladder, the less you need these things. So the objective is to get higher in the organizational ladder. Okay. So that's the objective. So try to get to a point where you don't need it because you are the CEO of the company. And I don't think for example, Elon Musk, the Steve Jobs, the Elon Musks, I forgot the guy from Microsoft. Bill Gates, yeah. They're not calculating derivatives and integrals. They got people to do that. But these are very smart people that they got to the place they got to, or the Mark Zuckerbergs. Mark Zuckerberg isn't calculating or isn't doing the algorithms for Facebook, but he knows enough about that to tell people what to do and what he wants. The same with all these other people. So the objective is to get high enough. Actually, I'm the highest position I've gotten here at CETIS is 2 steps before the presidency, which is the dean of the college. But I always ask to teach math classes. And one thing is that you notice I've got my notes here.
Yes.
After the class, and I'm going to do it right now, I'm going to rip these open. I don't keep these notes. Okay, why don't I keep these notes? And I don't have them in the PowerPoints or anywhere else. I have the solutions in the PowerPoints, but I have those kept. Always when I'm going to do an exercise for you guys, today in the morning, I was grabbing the exercises while I was having breakfast and I was solving them just so I could keep my mind fresh and doing those things. And I don't have to solve identities as part of being the dean of the College of Engineering, but it keeps my mind fresh by doing it. So, and I just tore up the exercise I was going to do, so I have no idea. I have no idea what's going to happen. Let's do this one and then I have no idea what I'm going to do here, so let's see what happens. So this is going to be one. Let's turn this into, there's a couple of ways we can do this one, by the way, as well.
I feel like Mauricio that you, so, I mean, tú sustituyes the one by putting
Let's see.
squares minus tangent.
Okay, let me, you can help me out because since I tore up the notes, if you did it already, then that'll be useful. Let's see, you substitute the 1 for?
For second to the square of x minus tangent square x,
Okay,
and then we substitute
substitute? Uh-huh.
the second, we put second x minus tangent x
Mhm.
multiplied by the same, but with the same positive.
Yep. That has to do with what we were talking about. So you substitute the 1 for second square minus tangent squared of x, which is the Pythagorean. Now, again, remembering that x plus y times x minus y is equal to x squared minus y squared, it would be really useful if here we could multiply this second x minus tangent of x, if we could multiply it by second of x plus tangent of x. Cool. That would be really useful because this would, but that's going to give us, a 1 again, isn't it? Well, let's see. So this is what you did, right?
No, I did, I put during the, and the,
And then-
second x,
Oh, you separated, yeah, okay. So you did it, I understand it. You did it backwards.
Yeah.
So this here is what you have in the numerator. Okay, and so, okay, what you did was that you separated that into second of x plus tangent of x and second of x minus tangent of x, going backwards. Okay, yep.
and we eliminate, and at the end.
And it's gonna be the same.
Yeah.
Lo desconjugaste. That's what I think.
And this is gonna be second of x minus tangent of x. These are gonna be eliminated here. And second of x plus tangent of x, and that's what we have there. The other way of doing it is turning everything into sine and cosine and doing what we've done up to this.
La mente del pueblo es como la de los master builders de la Lego.
You have the gift. You have the gift. Okay, we're gonna save this. We went long without a break. We're gonna finish it up here. But you don't have Spanish anymore, do you? Oh, okay. So that's good to know. So on Thursday, we can take a break. I went long because I forgot about the Spanish. Okay, so questions with this one?
Nope.
Okay,
One-on-one like in community.
okay, so